Okay, so what I want to do is now the next assignment, which is much easier than the first one because there's not a lot of moving parts. And this has to do with, again, time value of money, and the things I want to touch on is, you know, if you have a situation where you have to figure out your mortgage payments, or you figure out if you have so much money, how do you account for, you know, future and stuff like that. So I'll use maybe 3 or 4 PowerPoint slides just to talk about the concept briefly, take any questions. I think, but the way I like to teach is to talk about the concepts first. And so once you understand the concept, at least 95% of it, then when you start to apply it, at least we can have a better foundation to build off. So first thing I want to do is talk about the concept. And so please, if you have any questions, ask me, because if you don't get the concept, then I think when I go through the Excel again, you may feel like you were lost. So please ask me questions, okay? From a time value perspective, when we are looking at anything, obviously the reason it's called time value is the element of time. You know, so you could be so typically when you're looking at a time value formula, there is going to be a present and a future, and the amount that is present is called present value, or PV, and the amount that we are calculating it in the future is going to be obviously the future value. And so the moving parts are where you are starting from. Second moving part is how far you are heading out, how many periods, or n in this case. How are you growing, at what growth rate, which is the growth rate, which is typically in most textbooks you're going to find either R or an I, but it's a growth rate. So there are 4 moving parts in this case. Where you're starting from, which is the present value, how long you're going to let the thing grow, which is n. At what growth rate are you growing, which is R, and that will get you to the future value. Okay. Now, on the other hand, if you also want to say, okay, if I have something that I am going to get in the future, it will be a lump sum amount I'll get in the future, I want to figure out what is it worth today. You're basically using the same formula over here, and just flipping it around and putting the present value. So this is present value. The future value is this formula. So now you're turning the thing around. So if you want to know the present value of something that is in the future, you're looking at that future value, whatever that is. Let's say it was $10,000 in the future. And let's say n is 10 years, it's 10 years away from today, and you're going to divide it by 1 plus R again. So that's basically is a very, very fundamental formula for time value of money. 4 moving parts: present value, future value, growth rate, R, and N. Okay. So the way this would work is that if you have money that you are putting in, and it's going to grow over the time, and let's say in year 0 we put in 2,000, and we want it to stay in for 3 years, 1, 2, and 3. So the formula would be that I'm taking the present value, which is 2,000, and I'm taking 1 plus R, in this case is 5% growth rate, so it's 1.05, and I'm growing it for the number of years it's going to sit in there, which is 3 years. Okay. Next year I'm putting in 3,000, and again I'm looking at it at this time frame, and from a practical purpose, this time frame could be that I may need money for a down payment on a house, or maybe it is money for college, or whatever reason could be some period that you're looking at it. From a portfolio management for your 401k, that could be your retirement time frame. Retirement could be literally retiring, or it could be phase 2 of your life where you're going to do something else. Whatever it is, some N, you have an N out there, and basically how you are going to put in the money and what your quote-unquote plausible assumption is for the growth is, which is this R. You basically are trying to go in and plug it in this, and that's what it would look like. Okay. Now, when you're using Excel, obviously, you know, once we figure out how to not have to do multiple entries, we'll talk about it in the break. You basically can go do this very, very easily. Now, So in this case, we have money coming here, we're growing it. So this particular piece, if I don't put anything else, this 2,000 will grow to 2315 by third year. This one, 3,000 will grow to 3307, and so on. And so now, by the end of 2000, and in the third year, this is what I will have. A couple of nuances when it comes to time value of money. And one is that we have to decide when we're doing the calculation if in the period when we're starting to put the money in, are we putting it at the end of the period or the beginning of the period? And by that I mean is, for example, let's say instead of calling this 2000 and T0 and T1 and T2 and T3, let's say this is 2011. T0 is 2011, T1 is 2012, and so on. Now, if I have $2,000, if I put it at the end of the year, which means if I put in the money on December 31st of 2011, then obviously in the year 2011 there will be no growth because I'm putting it at the end of the year. Only growth I will get is for 2012, 13, and 14. Okay. Now, typically, the default analysis that is done for time value of money, the assumption is that you're putting it at the end of the period. Okay. Now, but that is not true all the time. Obviously, there could be a situation where you could be putting money in the beginning of the period. For example, let's say I turned this thing around and said that in 2011, instead of putting money at the end of the year, which is December 31st, what if I put it in the beginning of the year? In that case, what's going to happen is we are also going to make money that year for the full year. When you're doing that, this becomes one extra year, so this becomes 4, this becomes 3, this becomes 2, and this becomes 1. So just a nuance to be aware of. Default typically going to find like your mortgage payments, etc., they presume is always end of the period. If you get a financial calculator, or when we go to the Excel, you will see there is a place in the financial calculator. There is a key to say is the beginning of the period or the end of the period. And typically the calculators, maybe not all of them, most of the financial calculators set default to be the end of the period. And then now this one is the end of the period. So I'm going to take a pause to see if there are any learning gaps before I continue.
So you can put it in like a percentage or a fraction or something? Like put it halfway through the year?
Yes, you can do that.
3.5.
Yeah, you can do that. You can do this. You can create this on a monthly basis. I mean, you can do daily if you have to. If you want to really, if you want to get carried away with your Excel, yeah, you can do that too. I mean, the question you got to ask yourself is how much more accuracy you're adding by adding 10,000 more numbers in your Excel spreadsheet. But the answer is yes, you can do that. Which the important part is to understand. For example, let's say you're doing this thing on Excel. And let's say you were doing it. You got to check somehow. Maybe money owed to you, or if you're working, somebody got a bonus in the middle of the year. Then yeah, you can mathematically put in the formula to say my growth rate is 5% a year, but because I got the money only for half a year, I'm going to only use 2.5%.
Would it be more advantageous to divide, to divvy up the growth rate, or to put it at the end of your?
Depending on how accurate you want to make it, if you, when I say by accuracy, is that if it matters month to month, the rate fluctuates so much, then you want to make it more monthly because then the element of accuracy is there. But if the element of accuracy, for example, if I was teaching financial investment class, I'll basically tell students just use annual. But we're talking about forecasting 20 years from now. We don't have enough accuracy to really figure out what's going to happen 5 years from now, rather than figuring out what's going to happen 6 months or 3 months. So it really comes down to, when it comes to analysis, it really comes down to the precision. We think we got more precision by cutting it finer, but the reality is it is our assumptions that really translate into a precision. So if your assumptions cannot go deep enough to differentiate between an annual rate and a monthly rate, then why bother doing it a monthly rate? If you have to go monthly rate, I would take the rate and divide it by 2. If it's 6 months, divide it by 4. So those are the kind of thought process you want to think through from an analysis perspective, is to say, I'm adding a level of precision by doing it monthly or daily, but am I really making the analysis any better? Okay. Anything else? Any other questions on this one? Yes.
Before we want to Excel, my question on dollar signs. You also have this to the third row. Is that the caret?
Yes.
Okay.
Yep. Caret.
Or
Yep.
upside down.
Okay. Okay. So now, so next thing I'm going to get into. So we talked about so far a couple of things. One is that we have time, we have N, R. The other thing is that we could have amount of money that we can go forecast. Okay. Now, third thing I want to talk about is if your amount every period is exactly the same, and by that I mean is say in this example is 2000, 2000, 2000, 2000. It's exactly the same. Whatever it could 3000, as long as it's exactly the same, then obviously mathematically there are formula that does it for you, and I'm going to show you what one of the formula is, not for you to be able to use the formula, but at least understand what that means, and then I'll take you into the Excel file, so I'll show you what that is. So this way at least, again, my goal is to first talk about the concepts, and if you understand the concepts, when I go to the Excel, it will probably make more sense, okay? So the second thing I want to talk about now is that, okay, in this example, the numbers are different. If the numbers are different, this is the only way to figure out what the future will look like. One thing at a time. Now, in Excel, you basically will be kind of doing much faster, but you cannot have one formula to do it. The reason is because the only way you can use the formula that I'm going to talk about next is the numbers are exactly the same. And that those typically work when you talk about annuities. You're talking about somebody putting in exactly the same amount of money every month in the 401k. So those are the exact amount of money. And that basically, then you can simplify the mathematics, and the formulas become a little bit simpler. So what I want to now get into it, what happens, what do you do if the numbers are basically the same? Now, I'll give you a little nuance. Well, sometimes when I'm teaching finance to the undergraduate, I'll teach them, then when I want to test them, I will give them numbers like I would say 2000, 2000, 0, 2000. And they will think it is same because it's 2000, 2000, 2000. But I had a 0 here, so it's not the same. In order for this formula to work that I want to talk about next, it's going to be every period has to be exactly the same. Okay? Now, so the next thing, so here is how you would do it one step at a time. Just like we did before. You're basically taking this and you're growing it by 1 plus 064, 063, boom, boom, boom. So you did it now. So you can do it that way. Basically, just like we did over here. Basically, what we did was we took each one of them and grew it by number of periods. I'm doing the same thing, except in this case, the numbers are exactly the same. If the numbers are exactly the same, then there is a formula which looks like this, and Excel has that. And what this is basically is to say that if the annuity, which typically the lingo that is used, is exactly the same, and the formulas typically they're called PMT or the payment, then you can use this formula to say, for example, if I have, which is the one we did before, if I have a payment of $1,000, PMT is $1,000, and the R is 6%, and N is 5, I can plug it into this formula, and I will get 5637. I don't have to go through all this stuff. Now, for you math geniuses, I know you want to know more about math, but the rest of us who don't care, I'll just tell you Excel will do it for you. Now, when you come to the finance class, I'll make you do some of this by hand. Okay, but for this class, I just want you to understand the concept and be able to do it. Okay, so the learning outcome here is before I go to the Excel is today, tomorrow, present value, future value, N is important, growth rate is important. If you got numbers that are different period to period, you got to do one step at a time. If they're the same, you can still do it one step at a time, or you can use one of these formulas. Everybody okay? Now, so what would the formula look like? And we will go to the Excel. This is just a screenshot. When I go to the formula for Excel, this will pop up for future value. If I go and look under the formula, which we will in a second, this will pop up for the future value, okay? And now it'll ask you following things. What is the rate? Growth rate. What is the number of periods? The N, we talked about it. What is the PMT? 1,000 in this case. And are you starting from any present value? And then this is the type comes in. This is where you know, when I open, this is a screenshot, so I cannot do it. When I go there, you will see when I click on this thing, it'll ask, is it the end of the period or the beginning of the period? It is defaulted at the end of the period. It is defaulted, and most analysis you're going to find are always at the end of the period. That's how it is done, but you should be aware of it. Sometimes it could be the beginning of the period, and like Kyle said, what if you are putting in money in some of the period? At least you understand logically, conceptually, you can adjust the way you are doing your analysis to account for any period you want. But this is the nuances of it. Okay, so this is what's going to happen when we open up the file. The other thing you want to also think about, yes.
For period, would you do months or years?
Good question. I was going to get to it. Depending upon if you want to calculate, I mean, if your monthly payments is, I mean, if your payments are monthly, let's say it is $200 a month, then your periods have to be month and the rate has to be monthly. These three things have to be in sync: rate, period, and the payments. In sync in the sense that if payments you're putting in is monthly, and if you're going to do it for, say, 10 years, then you're going to do 10 years times 12 as a period. If your annual rate is 6%, then you divide it by 12 to get a monthly rate. So these three things have to be in sync. It's monthly, quarterly, semi-annual, whatever it is, they have to be in sync. Does that answer your question?
Yes.
Yeah. So let's go to the Excel file. Okay. So okay, so now the way you would do it, so let me get the formula showing. Just fix that in 1 second. Shoot, how will it show up on me? Damn it. So the formulas are obviously in the formulas, and you go under financial formula, and if I want to know the future value, I go to the future value, and this is going to open up. Okay, and as I am on this cell, it tells you what it is. You know, depending upon where I am, if I'm sitting on this cell, Felicia. Under the formula.
In the book, financial.
Oh, I'm sorry. Under formulas, and there are a bunch of formulas that go into financial. Yeah, let me do it again. Sorry about that. Okay, here we go. Formulas, and you got all kinds of formulas, trig formulas, statistics formulas. You can go nuts with it. Financial formulas, you go under financial formulas, and then you go find future value, and that's what's going to open up. So when you're in the rate, it'll tell you what it is, and it'll tell you right here. Use, you know, if it's quarterly, you're going to divide it by 4. If it is whatever, you want to make sure that your rate is in sync with what you are doing with the periods and the payment. Okay. When you go to the period, it'll tell you the same thing: the period, payment, tell what it is. Type. This is what it tells you. Type is a value represent timing of the payment. Payment at the beginning of the period is 1. Payment at the end of the period is 0, and that is a default or omitted. Okay, so it is set up to go to the end of the period. So the form, I mean, the homework I've given you is, and a rule of the thumb is, at least from the time value perspective, if you are silent on the period, then it is typically end of the period. But in the real world, when I've had this discussion, I always ask whoever I'm doing it for, when are you starting this thing, now or beginning of the period? And that this way I can adjust it. So, but Excel formula will do it either way. If I put in the 1, it'll assume it is the beginning of the period, and it's going to obviously compound. Basically what it does, it compounds it for 1 more year. When I put in the beginning of the year, basically I got 1 more year worth of compounding. That's all it is doing, is compounding for 1 more year. Okay. So if I want to, so basically what you want, so if I want the future value, I can do that. So this is how you would do it. Okay. Now, the other thing that I've asked you to do is also, I think the other thing I asked you to do was also look at the portfolio value. Okay, so the portfolio value, an example I've given you is I've told you to use, I think it is 6% payment is monthly, obviously it's monthly, and you put the payment is monthly, and then you do the calculation. It'll tell you what the future value is. So for example, let's just do some hypothetical number. Let's say, you know, you're starting, you know, and here's the present value. Okay, so you put the present value, payment, NPR, and so on. So depending on what you're gonna do, you can use these things. Now, when would you use both payment and present value? When do you think you would use that?
You're trying to find out the interest rate.
When you have, so let's give you an example. Let's say you had $20,000 in a mutual fund. That's your present value. If you don't put any more money in, i.e. PMT is 0, it will grow by say 6%. So this is where you're doing both. You have $20,000 in your mutual fund, that's the present value, plus you're adding $200 a month. And you're assuming it's going to grow to maybe historical rate of this mutual fund, whatever logic, plausible assumption. You can do whatever, it grows only 4%, whatever. But so basically, if you have a situation where you say, I got $20,000 in a mutual fund, I'm planning to add another $200 per month, then it basically do both. Grow your what you have today at that rate every year or every period, and also account for the new money you're putting it in. So this is a very good simple tool for, you know, people kind of forecasting their, you know, IRAs or mutual funds or 401ks or whatever. Okay. Any questions? Yes.
Could you like actually just do 2012
What
for that equation?
do you mean
Because
equation?
well, it says like, because I've tried it. Like, did you use that equation for 2012? For the
Not for this one. No, this is different.
Oh,
I was just
okay.
using my Excel file to just open this
Oh,
up. No,
okay.
no, I'm
I
sorry.
was
No,
like,
no.
how in the world
I just
is
no. That's very. This one I gave you basically is you are basically growing this thing. This is really reapplying the percent growth that I taught you today.
Oh.
Okay.
Okay.
Over here,
So,
and again maybe different. I mean, sorry, cancel this. Over here, the second, the third, and the fourth. This is where you are going to use it. Okay. I gave you one of these. I think I gave you the mortgage one. This is where you're going to use it. Okay. So yeah, this is. So let me go back to the. So let me go back and finish that conversation, and then I'll talk about the mortgage payments. Again, future value has got following moving parts. At what rate is it going to grow? How many periods you're talking? And again, rate has to be in sync with the period. If the periods are monthly, rate should be monthly, which means annual rate is 6%. You can divide it by 12. PMT is monthly PMT, obviously. Present value, if you have something to start out with. If you got nothing to start out with, then that's going to basically stay blank. And that's going to give you the number. So let's say, for example, let's say we had a situation where we had a 6% growth rate that we are assuming, but because it is let's say we're doing it for 10 years, and let's say we're putting in $500. Okay, it tells you right away. Now, one thing I will point out, and if you're doing it for the first time, the number you will see is negative. Don't worry about that part. Anybody should know what it is. Why is it negative? The absolute number will be the same. And the thing is, the way the logic works for the time value of money, that this implies that if you put a positive number of PMT, it implies you're taking money out. So the cash outflow, which means you're putting money in, is considered as a negative. So if you make this a minus, you'll get, so that's the number I got. So but anyways, if you're doing it a minus number, because basically the logic of time value of money is that I am outflowing it. Every month I am putting money out into my 401k of $500. That's minus to me. Eventually, as I keep putting it in, X years from now, it's going to be worth $82,000. That's positive to me that I can get it back. So that's the reason for the minus sign. If you don't do it, if you put a plus sign, you'll get a negative number in the end, but the absolute value will be the same. Okay. So that's the future value stuff. Any questions before I go to yes? Bob.
Is there a proper convention? Like, should we make it negative?
Yes. Proper convention is to make it negative, but is it a deal breaker? No. This way, at least when you're doing your files, they'll come out more. The output will be positive. Yeah, but for this conversation or this class, it is not a deal breaker. It's just so you know why is it coming out negative. And when you do the net present value, when you get in the financial class, you'll have the same issue. You got the negative set of negatives and the positives of positives. That's all. So, any other questions? Everybody okay? All right. So let's do mortgages. Mortgages, again, financials. This time around, what we want to do is to ask ourselves, which is what I gave you, is that a person is borrowing $200,000 for mortgage, and the bank has calculated for you. So I kind of give you the answer. At least you can test it to see if you get there. Bank has given you the calculation for what the monthly payment will be, and then as I'm sure many of you have looked at your mortgage documents, it'll tell you total amount to be paid over the life of the loan. It'll be some number, and then when you subtract from there what you are borrowing, you get what you're paying for the interest. So that's what you're trying to calculate, to figure out, to say, okay, my goal is to figure out, okay, so I'm going to do is to take these things out for a second, clear content. Okay. So now, here is the situation. This is what I gave you to do. Okay, and I think I gave you 200, so I'll go to 200. Okay, now, so this is the real live application, obviously, that we have all gone through in some stages, be for second mortgage or equity loan or whatever, primary mortgage. You go to the bank, they'll tell you it's 5% interest rate. Obviously, because it is a monthly payment, first thing you want to do is to either divide it over here or remember to divide it like I did when I was putting it in the Excel box. Okay. This is the mortgage, and this is the formula what we put it in. So I'm gonna tell you how I did this thing. Okay. So you're gonna go to formulas again, financials, and we're trying to figure out how much monthly payments will I pay. So I go to the PMT. PMT, the box opens up. It'll ask you for what is the rate that you're paying. Now, if I use 5%, then I should remember to divide it by 12. Or if I use this one, which I already did, so just have to, you can do it over here like I did before. Number of periods is going to be, again, because I am doing it for monthly, when I take this number, I should multiply that by 12. Okay, and I am borrowing at 200,000. Okay.
Did you just say that one?
No, hang on one second. I think I messed up. Hang on. So rate is, I'll just type it in either. The rate is going to be, let's say the rate is 0.05 divided by 12. Whatever you sell is, you're going to find it's easy to do this from here. Number of periods is going to be 30 years times 12. Present value I'm borrowing is 200,000. I know it's one over here. There you go. All right, one more time. Financial formulas. And the reason is this is something that you want to be aware of. Sometimes when you do it again, it keeps the last one and keeps adding to it. So I'm going to clean it up and start again. Payment. Rate is, I will use the cell. Typically I'll pull the cell in. So let me put the cell in. Cell divided by 12. Period. This cell times 12. Okay. Present value is this cell. I'm sorry. Down there. Present value is this cell. Yeah. Okay. Okay. So that's how you did it. I got the monthly payment, so I know if my mortgage is 5% and I'm borrowing 200 for 30 years, this is what I'll have to pay per month. Now, obviously, this is why you want to keep these as independent variables. So this way, you can say, maybe this is too high, maybe I should borrow less, so maybe I can get, or if you think you can refinance it, so this way you can kind of play with it. So now, to do this, basically, how do you think we do this thing over here? How do we get to the total amount collected over the period?
Payment times months.
Payments times the number of months you're going to pay. So basically, you're going to take this, and you're going to pay for 30 years times 12. So this is basically this number times the number of years, and times 12 because it is monthly. So basically 360 payments you are going to make, and for 360 payments you are going to be paying $1,074. And hence, how do I get to the total interest earned by the bank?
Subtract the principal.
You're going to subtract the principal because they already gave you that money. So they're giving you $200, and you bought the house. Over the life of the loan, you're paying them $386. So basically, they made $186 off you. Okay.
Never stops working.
And so what I'd like you to do as a homework assignment is to just fill these out. And I think you'll see, obviously, as you'd expect, these numbers are going to go up because you're paying it faster, so you have to pay a little bit more every month. But these numbers are going to drop a lot. You're going to pay a lot less interest, obviously, as you are paying it off much faster. Okay. All right, I'm going to stop here. Any questions? And then we will spend some time with Kyle and Bob and anybody else that wants to kind of go through the how I at least do with the trying to keep the the key F4 key. Right. So I'll stop recording.